We've grown accustomed to math being rigorous, like this. But if you're only looking for rigor, you're more likely to miss when math is really useful in our everyday. Because sometimes math looks like this. Or this. Even this. If you're not sure how math can help you improve gameplay, this video's for you. Though we're looking at DOA 5 specifically, these concepts apply to DOA 6 and other fighting games too. Every hit you land, block you perform, or round you win is part of an underlying counting system. While the game doesn't show you raw numbers for everything, damage output, combo chains, match history, and win streaks are all structured around counting systems. The combo sequences, you could think of them as mathematical permutations or combinations. Though every permutation is not available, it helps you quickly identify which permutations are missing, and therefore which combinations are not valid inputs for any kind of combo. DOA tracks how many times you've used each character. Costumes and titles are unlocked after certain milestones. Every time you win with a character, you get a costume. And then there are certain milestones with each character. So like after 10 wins, you'll unlock a new title, 20 wins will give you another title, etc. This reward system is based entirely on counting, and knowing how many matches you've played helps you predict what's next. During gameplay, the health bar is a real-time subtraction problem. Each hit reduces your total. In some modes, and with certain moves, you may even regain a portion. That's addition. Every one of these systems is arithmetic in disguise, and the more you recognize how the numbers behave, the faster you can adapt your play. Algebra is about working with unknowns and relationships, and DOA is filled with them, even if you've never seen the equations. Every fighter, object, and camera in DOA exists in a 3D space. Even though you don't see it, the game constantly tracks position using coordinates. X is left and right, Y up and down, Z depth into the screen. When you sidestep, jump, or get knocked across the stage, you're watching real algebra at work, with variables changing values every frame. A lot of the game's logic depends on values you can't see, things like frame advantage, input buffers, or hitbox positions. These are variables that drive outcomes. If input A is pressed while state B is active and distance D is within threshold, then output C happens. That's textbook algebra. It might not look like y equals mx plus b, but rest assured, you are performing algebraic approximations. Even though it's not fully exposed, every fighter has stats: movement speed, attack power, range. These aren't labeled in the game, but have numerical values. You may not know the exact value, but through play, you build a mental model. This move is slower. This character has long reach. This combo stuns for longer. That's abstract reasoning, the heart of algebra. Understanding algebra helps you read the game faster, because it helps you work with what you can't see directly. You don't need to write out equations to think algebraically. If you're predicting outcomes based on hidden states, manipulating positioning, or testing cause and effect, you're using algebra intuitively. Geometry is the math of space, shape, and position, and DOA runs on it. From side steps to stage layouts, geometry shapes every match. Many moves like spin kicks, jump punches, or sweeps operate long arcs. You're not just punching forward, you're tracing a curve through space, estimating angles whether you're realizing it or not. Understanding which moves sweep horizontally versus hit vertically is spatial reasoning in action. The environment isn't just background, it has real effects. When a player is launched into the wall, they're reflected back. When they hit a slope or ledge, their angle of movement shifts. This is basic geometric reflection, similar to how light bounces off objects ricocheting in physics. Geometry isn't just diagrams on a whiteboard, it's how you see a fight unfold. The better you are able to understand space, shape, and angles, the more control you have over what happens next. Geometry gives your instinct structure. The math is already there, all you have to do is notice it. Statistics is the math of patterns, outcomes, and decision-making under uncertainty, and it's everywhere in DOA. At its core, DOA operates like a rock, paper, scissors system. Strikes beat throws, throws beat holds, holds beat strikes. Now I realize that's a pretty severe generalization. Obviously it feels cleaner than that. It feels more enjoyable than that. So unlike a clean one-on-one game of chance, DOA adds rhythm, memory, and habits. Over time, players develop statistical intuition. This player throws after blocking 3 out of 5 times. He favors high holds when he's low in health. Every defensive choice, block, hold, sidestep, is a statistical strategy. You weigh the probability of what your opponent might do and respond accordingly. Even if you're not tracking the numbers explicitly, your brain is modeling the frequencies and tendencies of your opponent's behavior. This is predictive modeling, and its core statistical reasoning. When players go into training mode, they often repeat scenarios. How often can I land this combo? What's the punish window for this block? You're literally running experiments and collecting data, trying to increase sample size and find reliable outcomes. That's the essence of statistics: testing, recording, and adjusting based on patterns. You don't need a calculator to think statistically. You just need to notice patterns. Every time you say, they usually do this, or that move lands often, you're really doing statistics and using it to win. In summary, when you're playing DOA 5 or 6, you are experiencing mathematics in real time. Math makes it all possible, and the more math you know, the easier it becomes to reverse engineer the game, giving you an advantage over other players. If you don't feel like you're good at math, but you rock at DOA 5, maybe you just haven't given math class as much focus as you've given video games. When's the last time you did math for 100 hours? Not spread across different topics or disciplines, just one topic, like algebra. Just like watching someone else play the game doesn't necessarily make you better, you need to be the one doing the mathematics to improve. And based on what you can do in a game like DOA 5, you're probably better at mathematics than you realize. As a society, we've kind of come to expect mathematics to be hard or complicated. And when it's not, when it seems easy, when it seems second nature to us, or like we can intuitively do it, we almost discount ourselves and start saying things like, that's not really mathematics, or that's not as impressive as, so-and-so, or doing the other thing. But that's not true. Not everybody can play DOA 5 in the way that you play it. Not everybody can do what you can do. And people just naturally get into these video games. They naturally get into them, and they naturally find patterns and identify ways to improve their performance based on the data that they find and the data that they pick up. That's mathematics. That's what it's about. You don't need to have the rigor of mathematics in your life in order to really enjoy the benefits of leveraging mathematics on a regular basis. Oftentimes, it's just playing a game. And as you play, you're able to find ways to improve your score, find ways to more efficiently do something. Whatever your game style is, mathematics has something to offer you. And if the rigor of a classroom setting isn't the right kind of math for you, that's okay. It just means continue to try to study mathematics on your own in your own way and in your own time. Thanks for watching. I hope this provided you a bit of encouragement for mathematics. If you have any further questions, or if there's anything I didn't touch in this video that you feel like I should have touched on, let me know in the comments.